Hello everyone. Today I want to introduce a few node group for handling the curve. So the first one is 3D field curve. In regular For the regular field curve node in some geometry node, it will project it back to 2D, which is not ideal. We want to somehow fill this curve in 3D. So we need a 3D field curve. So here it has three tabs. The first one is use curved mesh tab and extract the caps of the tool. The middle one is using this field curve node internally and then sample the position back. And for the first extrude version, it just extrude this curve and towards to their center. That's the three different tabs. And this caps usually gives you the fast result, so that works on most of the case. The second one is catenary. This one is really helpful for some ropes or stuff like that, maybe string or something else. You want to distribute a bunch of ropes, and here you can tweaking the length of it, and this is physical accurate without any simulation and running pretty fast. So you can tweak the length, make it more longer, make it longer here, even longer. That's very interesting. And one more thing is that you can actually give it a little bit of rotation. You can make the endpoints at a different height. So here, if I give it a little bit of rotation around something around the y-axis, let's see, and you can see that one still gives you the accurate result, even they are not at a different height. So this is a very good tools for this distribution here. The third one is a cones pouch, which gives you a closed curve and then it will generate a grid field for it. I think this algorithm is being used inside the mesh editing mode, and you can press Ctrl F to get the grid field. Yeah, I think this algorithm is the same. Here you can see this grid field, and this only works if the curve, like you have a square curve. So here, for example, each edge will have a pretty similar point count. So that will give you the best grid field topology. Otherwise, for example, there you only have three vertices, and here only have three vertices, so the grid field will be a little bit weird because there is some points will locate on this edge and on this edge. So only a few points on here, so that grid topology isn't great. So this cone patch only works best if you have something like a squared topology curve. So that's it. You can tweak the position of it, and you will see this one generating a pretty smooth surface. And here you also have the offset, just like the grid field option. You can rotate this grid topology here. The next one is curve intersection. And there is a working PR about the curve intersection for a long time, but still not been merged into the main branch. I don't know why. So this node can handle the curve intersection, include the self intersection. Here we can see this one is a single curve, and without a self intersection, you can only detect this with the other curve with the self intersect option toggled on, and it will also detect the self connection. but that will be much expensive. So because currently, this method is just a little bit of brute, I would say. So I will update. I will optimize it later. I will try to figure out a better way to do it. And you can also wire a custom geometry, something like a mesh, into this collision option, so that it will also get the extra point from it. So for example here, I'm gonna just do a simple cube here. Yeah. And you will see it will also generate this point. So that's 3 points from this collection geometry. It will intersect with this one. And here is the tolerance. So if you turn it up, and for the curve intersection here, it will have high tolerance. So this point will all marked as intersect. So you really just keep it at a very low value. That should be fine. And from this point, you also have two informations about what this point is intersect with. So for example, this one, it will intersect with the cube. So that will get nothing. Let's look at this one. Yeah, I think, yeah, there is actually 2 points, as you can see. They are pretty at the same location. So yeah, there are 2 points, and for this point, it will hitting to this curve. This point is from here, this curve, and shooting away to this curve. So for this point, you will have a information. It will know the information about this curve index and the hit location, the factor at this location. Similarly, for this curve here, when hitting, when shooting a ray to this curve, and it will know this curve index and the location and the factor and this curve location. So that's two informations. The next is a sphere packing. Here we can see we have a geometry, we have a curve, and after running this algorithm, you can also make more spheres. That's just for iteration. So for example, you have one, you will distribute one spheres, and so on and so forth. And you can tweaking the curve radius, and the curve radius will affect the sphere radius. So this is pretty helpful if you are doing some juries. The next one is the curve deform. So this one is similar to the deform modifier of the curve deform. So where we have geometry and we have a curve, and then it will deform along the curve. By default, it will fit it using the object z location, z coordinate. So if you want this object to fit the whole curve, you can tap this option on, and it will automatically fill this whole curve. And for each object, you can also give them an attribute. For example, here, you can have a curve here. This one as 0, and you can duplicate the cube, and you mark it as 1. So here, if you have two curves, let's show you an example here. So if this have a two curve, and you use this curve to find the corresponding curve, then it will have two different. It will find their corresponding curve index and deform it along that curve. The next one is the curve rolling. Again, this one is also physical accurate, similarly as this category. So as we can see here, we will define the d, which is the 2 multiplied by the radius. And you can control the animation here by a single factor from 0 to 1. Then this one will be rolling, and this one is physical accurate. As you can see, it perfectly aligns the shape. As you can see, it works so good, and you can also taking the start radius of this variable, and that will still be very correct. You can lower this one, as we can see. It's just aligned so perfect. So I bet this one is, yeah, you probably never see this one. And next one is the edge bundle. So what is the edge bundle here? It's just a instance a bunch of the lines, and then running this algorithm, it will snap them together to form like this shape from this bundle shape. The next one is hair meshed curve. Here we have a few examples. Let's watch the first one. For example, if your hair mesh is something like this plan, grid topology here, symbol plan, and then that is a curd tab. Uh, so you select the plan and the curd here. Let's say the mesh tab and the plan topology here. Let me just drag it wider here. And then it will find the center line, which gives you the original hair curve. So that's the first tab. The second one, for example, you have the triangulating mesh. If you export the mesh from something like Unreal Engine or other game engines, so they use the triangle mesh here. And then here we select the triangle topology, and then it will also detect the original hair curve. And the third one is, for example, you have a, let's say, subdivided grid, something like this. So there is a line in between. Then you will need to select the subdivide topology here, and then it will also find the original hair curve. Then we also have this tube topology. So for this tube topology, it only works if you have this kind of cap. So there, all these points are not being merged together. So if you using this kind of curve here, then that will be wrong. As you can see, something's wrong out there. So it only works with this kind of topology. Now this, you merge it to a singularity point. That won't work. So for this curve topology, for this tube topology here, and this is a different match tab. The previous three is plan tab, and this one is a tube tab. The last one is a UV based mapping. So where we define a UV map, this one will require that your hair UV is perfect axis aligned, just like this mesh, or rotate 90 degrees, align to X, something like that, or align to Y. It only works with this kind of axis align. And here you will define either align to X or align to Y to find this center line. So we also have a loft curve here. We input a fill curve, and then it will create the smooth surface from this curve. And we can also toggle the cyclic or not. So you can moving it and do whatever you want. And this is a resolution. So we can make it a coarse mesh or more denser. This is a grid topology. Also, we have a UV map. Also, we have this line here, which is the topology lines for some use case. Also, cyclic, you create all these topology lines. The next one is a wave curve. It's useful for some higher waves or this kind of topology if you want to create something like this. Here we have a few settings. The period just to control uh, the period of these waves. The count is just the last name here. I can make it more not, so it will look like this, or just a few dots. The radius, just the main radius of this profile, and the strings is the strings of this wave. So that's all the tools. So hope you enjoy it. Yeah. So I will update it in the future if I found something else or useful, some useful curve tools.